If you didn't like the traditional UDV format for integration by parts, then this video is for you because I will show you guys how to do the DI format for integration by parts. Let me show you guys how it looks like first. So we first put down the D and then the I, and then on the side we put down plus and the minus. Sometimes we may need to continue just plus minus, but this right here is okay just for demonstration purpose. The truth is, this right here is the same as the integration by parts. This is not like a whole new different method, but it's just a different way to set it up. That's why I call this the DI format. Sometimes people also call this the DI method, but don't confuse this as like a whole new different method. Have a look right here though, I'll convince you guys this real quick. Last time I told you guys when we have the UDV, we just first put it down like this. And as you can see, we will have to differentiate U, and that's how we get the du, and we will have to integrate dv, that's how we can get the v. Originally, we are looking at the integral of u dv. And if you run through the formula, well, we first do this times that. That will be the first part of the answer, which is uv. And then we will have to multiply these two things in a row, but we will have to subtract that and we put them inside of the integral. So it will be a minus integral this and that inside here, which is v du. So that's exactly what we were talking about in the previous video. But if you do it this way, if you set it up like this, it's going to be so much cleaner, more organized, and overall just much better, and you will be happier. Let's take a look at the first one, the integral of inverse tangent of x. Remember, whenever we're trying to integrate inverse functions, most of the time we use integration by parts. Well, now let's go ahead and put down d and then I, the DI format, and then the plus minus on the side just to get ready. Well, am I going to put down the I for the inverse tangent of x? No, because that's exactly what we're trying to do. So it will be redundant. With that said, we will actually just differentiate inverse tangent of x, and we will be integrating 1. Differentiating inverse tangent of x, remember your derivative, we get 1 over 1 plus x squared. Integrating 1, we get x. This right here, we stop because I really don't want to keep going to differentiate this guy. Likewise, if we keep integrating this right here, it seems no end, right? We need to have a sense of danger, so we stop right here and then just go ahead, construct our answer by multiplying this and that. That will be the first part of the answer, which is x times inverse tangent of x. And then we multiply these two things together, put that inside of an integral. This we will have to minus integral this times that, which is just x over 1 plus x squared dx. The truth is, we stopped right here perfectly because when we multiply this and that, this is an integral that we can integrate. So, whenever we can multiply the product, we get an integral that we can integrate, we just stop. Let's see how we can integrate this right here. We'll do the u substitution. And see, this is just so much cleaner. There's no like a u dv, vv, w, xyz, happy face, over the place. None of that. Clean, simple, better. Now let's take a look right here. We do by u sub, so I will put this. Actually, let's try this first. Let me show you how we can do u sub in your head. Not to show off, it's just, well, maybe a little bit, but you also need to know how to kind of show off in calculus too, because if you don't know how to do this, sometimes a lot of questions will be just really long. So here's the deal. We do u sub. Let u equal the bottom, and when we differentiate that, we get 2x. On the top, we just have x, so we need a 2. So we multiply this by 2, we divide it by 2. So we have a 1/2 right here, and that's a minus. And then we will just integrate 1 over u. That will give us ln of the bottom, which is just 1 plus x squared. But 1 plus x squared is always positive, so we don't need the absolute value. Just put on parentheses, that will be okay. And then we just write down the first part, x times inverse tangent of x. Minus that, and we are all done. Put down the plus c. Everybody be happy. Alright, now let me just run through the u substitution. for you guys real quick. We are going to let u equal, and you see, when you do use substitution right here, if you use the UDV format, then that's a lot of u's. That's, but anyway, it's the blue u. Let u equal the bottom 1 plus x squared. Du is 2x dx. Divide this on both sides. We are looking at dx equals du over 2x. Take this integral to the u world. We get the integral on the top is x over the bottom is the u. And then dx is that, which is du over 2x. Well, this is nice because the x cancel out nicely, and then we have 1 over 2, put that in the front. And then we are looking at the integral 1 over u du. That's just 1 over 2. Integrating this, we get ln u, which is that. Because this is always positive, you can just put on parentheses, and this right here is exactly what we got right here. So perhaps if you want to match the color, the subtraction is still in red. This part is the blue part that we have. And now I would like to show you guys 4 more examples so we can get a better idea of the DI format. You are really going to like the second one. We have to integrate x to a second power times sine of pi x. Well, we will be using the DI method, of course. You are really going to like the second one. We have to integrate x squared times sine of pi x. Of course, DI format. So let's go ahead and put that down. And the truth is, whenever we are trying to integrate x to a positive whole number power times sine or cosine, and then if the inside is just whatever x to the first power, you use integration by parts. And of course, you do the DI format. Have a look. In one of the video, well, in the previous video, you are really going to like the second one. We have to integrate x squared times sine of pi x. And the truth is, whenever we have to integrate x to a positive whole number power times sine or cosine, and then if the input is just whatever times x to the first power, we use integration by parts. Better yet, the DI format, of course, the DI method. Alright, d and then I, and then put on plus or minus. In fact, we need to keep going a little bit more, but let's just put this down first. Just like one of the questions in the previous video, we will actually be integrating the sine part. So sine of pi x, and then we'll be differentiating x squared. If we differentiate that, we get 2x. And if we integrate this, the integral of sine is negative cosine. So put on negative cosine. And then the input stays the same. But remember, we will have to divide it by the derivative right here, which is going to be just multiplied by 1 over pi. Okay, that's what we have. But the truth is, can we keep going? And the answer is yes, because we can totally differentiate 2x. And it's going to be smaller power. Right here, we can, of course, keep going and keep integrating cosine of whatever times x to the first power. Alright, so let's keep going. But here we have plus, here we have minus. We will have to alternate the side. So the next will be plus, and if you need to keep going, will be minus, and if we have to keep going, will be plus. The reason is because, remember the formula, right? We minus the integral, and if you have to minus the integral, then you will just add the integral. That's pretty much the idea. Anyway, differentiating 2x, we get 2. And then let's see, integrating negative cosine, we get, because the integral of cosine is still positive, sine, so this negative stays, and then we have sine, and then the input stays the same. But we will have to divide it by pi again, so we get 1 over pi squared. Can we keep going? Yes, because when we differentiate this one more time, we get 0, and then we can of course do this again. Integrating negative sine, we get positive cosine, so we will just have cosine, and then pi x, divided by pi one more time, so that's 1 over pi to the third power. This is a stop, because we have 0 in the D column, we stop. You can see, because if you keep going, it's just always 0, so you of course stop. Now, the beauty of the DI method is that once we have this, we just multiply the diagonals. And don't forget to take the sign with us as well. And that will be the answer. So ladies and gentlemen, the first part of the answer is going to be this times that, which is negative 1 over pi x squared cosine of pi x. Next, this times that is positive 2x. I'll write it as positive 2 over pi squared. And then the x. And then we have the sine of pi x. And the last one is this times that, which is going to be plus 2 over pi to the third power. And we have cosine of pi x. Guess what? We are done. Plus C. Because we finished all the integrations in the DI table over there already. That's it. For number 3, we'll be integrating ln x over x to the second power. And let me just tell you guys that whenever we integrate x to some power times ln x, we do integration by parts. And we'll be choosing this for the D column. So you see we have the 1 over x squared, and that's just the same as x to the negative 2. So it's in this form. Let's go ahead and make this happen. D and also the I plus minus. We will be differentiating ln x and then integrating x squared on the bottom. So that's right as x to the negative 2. So when we do that, we get 1 over x. When we integrate x to the negative 2, we add 1 to the power, which is negative 1, divided by the new power, so we get 1 over negative 1. That's going to be negative, and here we'll just have 1 over x. Yeah, x for negative 1, just like that. Now, this times this is the first part of the answer, so we will have negative ln x on the top over x. And then we are going to multiply these two things together. Minus times a minus, so in this case, we actually have to add an integral and then x times x on the bottom, which is going to be x squared, and we can write that down like so because it's on the bottom. And then we have the dx. So let me put this down in black. I know we integrated this earlier, but let's do this again. Add 1 to the power, which is negative 1, and then divide it by the new power, so we have negative 1. So all in all, we have negative ln x over x minus, and then we have x to the negative 1, which is just 1 over x, and then we are all done after we put on the plus c. That's it. For number 4, we have the integral of e to the 3x times sine of 2x. And this right here is a repeating case. I will tell you guys what I mean by that later. For now, let's just go ahead and do the d and also the I and just set it up. Let's see what happens. Okay, so now let's see what shall we choose to be integrated. E to the 3x? That seems doable, okay. How about sine of 2x? That's also easy to do. The truth is, whenever we are integrating e to the whatever number times x to the first power, and then times sine or cosine of like whatever number times x to the first power. Whenever we have that, that will always be a repeating case, and it actually doesn't matter which part we choose to be integrated. In the end, we'll end up with the same answer. So for now, let me just put down sine of 2x right here, and I will be differentiating e to the 3x. If you switch this, don't worry, you and I will still have the same answer at the end. Let's just go ahead and do the work. Differentiate this one time, we get e to the 3x, and use the chain rule, we multiply by 3 right here, and that's also integrate sine of 2x. Integral of sine is negative cosine, and we keep the input, and because the derivative of 2x is just a number 2, so we just need to divide it by 2 right here. Okay, so that's good. Should we stop right here though, or should we keep going? Well, the truth is, we actually will need to keep going, because notice that if you look at the function part, e to the 3x times cosine of 2x. That's why I said earlier, we will have to use integration by parts for those kind of integrals. So, the beauty of using the DI setup is that if we need to use integration by parts, if we need to do it again, just go ahead and keep going. That's all. So I will just, okay, we have a plus, minus, and then we'll just extend it. So we have a plus right here. And then we will just differentiate this one more time. We will still have e to the 3x, and then we will have to multiply by 3 again. So that will give us a 9 right here. And then for this, integrating negative cosine, that will give us negative sine. And the input stays the same, but we will have to divide it by 2 one more time. So we have 1 over 4 right here. And now, this is the time that we are going to stop. First, why don't we keep going? Because if we keep going, yeah, this right here will just keep on going forever, right? Likewise, we can always do this as well. It can keep on going forever. So again, we should have a sense of danger. But the better reason that why this should be stopped right here is because look at the function part. Here we have e to the 3x, and here we have sine of 2x. This is the repeat from the original integral. Whenever we have this, we stop. Right? So that's the real reason why we stop right here. And let's just go ahead and construct our answer. So as usual, this times this, that will be the first part of the answer. And however, whenever we have a repeating situation, let's just go ahead and write this down again. So I will do that right here. Integral e to the 3x sine of 2x. Alright, the first part of the answer is this times that, and that's going to be negative 1/2 e to the 3x cosine of 2x. And the next, this times that, again, no integral. This is another part of the answer. We will have negative times negative, so that's positive 3 over 4, and then e to the 3x, and then sine of 2x. Lastly, when we multiply this and that in a row, you put that inside of an integral. So again, diagonal, they are just going to be no integrals. They are going to be the first, the second part of the answer. But here, because we stopped it right here, we multiply this row. We put them inside of an integral. We have positive 9 times negative 1 over 4, so that will give us negative 9 over 4. And because this is just a constant multiple, so you can put that in front of the integration sign, and then we'll put the rest inside of the integral, and then we have the rest, right? E to the 3x, and then sine of 2x dx. Alright, so now you see, we have this on the left-hand side, and we have this on the right-hand side. This is just like the good old days. Let me show you. If we are trying to solve an equation, let's say we have y is equal to 1/2, negative 1/2, and then plus 3 over 4, and then minus 9 over 4, y, things like this. What do we do with this? Well, we just move this to the other side by adding 9 over 4 y on both sides. The good old algebra day, remember? Right now, it's the calculus days, and we still do the same thing. So right here, we can actually just add 9 over 4 integral of this. And it seems like this is a lot of work. It is. But it's just that we are writing a lot of the same thing over and over. But anyway, we are adding this integral on both sides. So I'll put that down right here. We add 9 over 4 and the integral e to the 3x sine of 2x. So that this and that can be cancelled nicely. Okay, so here is the deal. We are just adding this and that. This right here is one integral, and then we have 9 over 4. So this is the same as 4 over 4. Plus that, we get 13 over 4, and then times that integral, e to the 3x sine of 2x, and then dx. And then again, we just pretty much write this down, right? So this is equal to negative 1/2 e to the 3x times cosine of 2x, and then plus 3 over 4 e to the 3x sine of 2x. We are not done yet because we have 13 over 4. That's not what we want. We want just one integral, right? So we're just going to multiply everybody by 4 over 13. So that this and that cancel, this and that cancel. So let's just go ahead and do that. So I'll put down 4 over 13, and then also 4 over 13. Yeah, so I'm going to put that down. right here, the integral of e to the 3x sine of 2x. Ladies and gentlemen, this right here, again, this is just a multiplication, so we can cancel and we just get 1 and 2. So 2 over 13, negative, right? Negative 2 over 13. And e to the 3x cosine of 2x. And then 4 and 4 cancel precisely, so plus 3 over 13. And then we have the rest, e to the 3x times sine of 2x. Yeah, that's it. So be really careful when you are doing this kind of questions. In fact, I did this previously. This is actually a re-upload. That's why you might see like a slightly different part for this part. Because I multiplied 9 and 1 over 4 wrong. Right, check this out. Positive times minus, so it's negative of course, so we minus. And then we have 1 over 4 and 9. It's just a constant multiple. We can put down the outside. And then the rest goes inside of an integral. Anyway though, I believe this time this is correct. Almost. Plus c. Yeah, so this is it. Okay, number 5, we'll be integrating x plus third power over e to the 2x power. Here's the deal. It looks kind of weird, but it's actually not so bad because we can use the rule of exponent and we can rewrite this as the integral of x plus third power times e to the negative 2x. So this will be a little bit more friendlier for us, right? And this right here will suggest us to use integration by parts. And we will be taking x to the third power for the d right here, and then I will put down e to the negative 2x right here under the I. And in fact, we can actually finish this and get the 0 from the d column. So I'm going to just put down a couple more, and we see 3x squared, 6x, 6, and 0. So that means we should also integrating this many times. Okay, go ahead. E to the negative 2x, but we will have to divide it by negative 2. So we have negative 1 over 2. Next, e to the negative 2x, and then divided by negative 2. So that will give us positive 1 over 4. And then do it again. And then divide the negative 2 again, so it's negative 1 over 8. One more, e to the negative 2. And then that will give us positive 1 over 16. Ladies and gentlemen, 1, 2, 3, 4. Yeah, 4 parts. And then that will be the answer. So for the rest, we just have to write it down. So let's see, negative 1 over 2, x to the third power, e to the negative 2x. And then positive times negative, so it's negative 3 over 4x squared, e to the negative 2x. And then just continue. Reduce this though, 6 and 8, which is 3 over 4, but that will be a minus because of that. Minus, and then 3 over 4 x, and then e to the negative 2x. And lastly, again minus. So 6 over 16, it will be 3 over 8. And we have e to the negative 2x. Yep, and then just put on plus c. Yeah, I put the most satisfying one for the last question right here, right? So hopefully you guys find this video helpful, and if you guys need more help, you guys can check out my other videos, especially for integrations. I have tons of videos on that. And if you have any questions, you can just leave it in the comment section down below. Alright, so maybe I'll see you guys in the next video for the next topic for integrations. That's it.